What are you doing, Mr. Lemon?
As you can see, I am doing the experiment of decomposition of hydrogen peroxide.
Amazing, but what is it used for?
Well, in many industries, the decomposition of hydrogen peroxide is used to produce sodium perborate and sodium percarbonate, which are bleaching agents in solid and liquid detergents.
It sounds important. But I heard that the process of decomposition is slow. So what could we do to increase the rate of decomposition?
Good question. Well, there are two methods, which are temperature and the presence of catalyst. With the presence of a catalyst, the reaction occurs at an alternative path with lower activation energy. So more reactant particles can achieve the lower activation energy. The frequency of effective collision between the particles is higher. On the other hand, the higher the temperature, the higher the kinetic energy of the reactant particles. The frequency of collision between the fast-moving particles is higher. In these ways, the rate of reaction increases. Lily, let me show you how the catalysts look like. Here's my friend's research laboratory, and he will show you some examples of catalysts. His name is Professor George.
Alright, let me explain about it. Here are the examples of catalysts. Manganese 4 oxide. Potassium dichromate 6. Goethite, a mineral consisting of iron 3 oxide hydroxide. Let's check out the price. Manganese 4 oxide is Rm 0.03 per gram, whereas potassium dichromate 6 is Rm 0.13 per gram and goethite is Rm 0.06 per gram. As we can see, manganate 4 oxide is the cheapest compared to the others. Other than that, we can increase the temperature instead of using catalyst, which triggers the reaction of thermal decomposition of hydrogen peroxide. However, this method is quite dangerous and not advisable to carry out, especially for concentrated hydrogen peroxide, because it will decompose explosively when heated above its boiling point at 150 degrees Celsius. Therefore, using a catalyst is a better way to increase the rate of decomposition of hydrogen peroxide.
Thank you, Professor George. Lily, what have you learned today?
Mr. Lemon, from what I understand, we should choose manganese 4 oxide as a catalyst to increase the rate of reaction. The reason is catalyst remains unchanged in most cases and is thus reusable. Furthermore, manganese 4 oxide is easy to obtain and affordable. On the other hand, we do not heat hydrogen peroxide directly. Heating hydrogen peroxide causes it to lose stability and decompose into both oxygen and water. The reaction is exothermic. The oxygen released can combust if it mixes with fire and therefore can cause an explosion.
Good. You're always learning new things and trying to better yourself. That's awesome.